Hello everybody. This video is about our upgraded IFF SDK online demo with the precision clock. Last year, we released a video about our online demo that was launched in 2022 and has been running ever since. Crow's Nest is its name. It shows how MRTech IFF SDK can be used to stream video from a machine vision camera connected to an NVIDIA Jetson module to a client's browser. This is how it works. Images from the camera are processed on a Jetson Xavier NX module, encoded and streamed to the network. We installed a WebRTC server application on a remote server hosted by OVH Company in their data center in Frankfurt, Germany. We have upgraded the setup by adding the Mitxela precision clock. The time on this clock is automatically synchronized to the GPS satellites and displays an accuracy of 10 milliseconds. Now we can estimate the delay between the moment the camera receives a particular image and the moment the image is displayed on the user's monitor with high accuracy. This time interval is known as the glass-to-glass latency or G2G latency. We place the clock under the roof window so that the antenna on the clock can see the satellites. Let's start the clock and wait for it to synchronize. It can take some time. When the clock is synchronized, the colons on the clock will start to blink. This shows that the clock is synchronized every single second and the time is stable enough to use it as a reference for the measurements. For example, to estimate the glass-to-glass latency for the case. We will show you in a second. Other than the use of the clock, the online demo setup and its functionality remain the same. XIMEA camera with 3.1 megapixel resolution and PCI Express interface is connected to the NVIDIA Xavier NX module. The camera is pointed at our precision clock. The Xavier NX is running the IFF SDK-based application which processes and streams the full-frame images from the camera to the network. Now that the clock is synchronized, let's go to the receiving end to see how the demo works. We used our MSI laptop as a receiving station. On the default screen of the Crow's Nest webpage, the user can view the video stream, control it, stop it, and manage the viewing window. On this tab, we can change exposure time, image white balance, and camera gain using the cam element. Please note that auto exposure and auto white balance are enabled by default, so you should switch them off using the auto control element if you want to change exposure and white balance settings. Look how it operates. The important thing we want to show at the end of this video is to measure the glass-to-glass latency that Crow's Nest can provide. To do this, we'll point the camera from our setup at the clock and the laptop screen simultaneously so that we can see multiple sequential images, the previous one inside the next. If we stop the picture on the screen, we can estimate the latency from the camera glass to the screen glass with an accuracy of 10 milliseconds. Look at this. Glass-to-glass latency for our case is at most 100 milliseconds. In our view, that's an amazing result considering where our WebRTC server is located. If you would like to try the online demo, please contact us for access to the Crow's Nest. There is more information in the description of the video. Thank you all for watching.